Let's look at the complete the square method for solving quadratic equations. The complete the square method is one of the ways that we can solve a quadratic equation that can't be factored, because we need other methods when it's not factorable. So it comes from the idea of when we have a perfect square trinomial. So what is a perfect square trinomial? It's when you have a situation where one half of your middle term, so for this example, half of 4 would be 2, and you square that number, you would get 4, which is C. And another way to look at it is your factors would be identical for a perfect square trinomial. This would factor into x plus 2 and another x plus 2. So it can be rewritten as x plus 2 squared. So that simple idea helps us to rewrite any trinomial so that we could turn it into something squared and use square roots in order to solve it. So we can turn any trinomial into a perfect square trinomial. I abbreviated it as PST so that we could use square roots to finish solving. So let's write down our steps and look at some examples. So your steps, and these will make more sense when we look at the examples. First, you want to write your trinomial in standard quadratic form, which is ax squared plus bx plus c equals 0. So put everything on one side equal to 0. Then you want to check if a is not equal to 1, you want to divide everything by a, whatever that value might be. Number 3, check to see if c is equal to 1/2 of your middle term coefficient b squared. And if it's not, then move c to the other side and add plus blank to each side of your equal sign. Then you want to rewrite, so now you've made it a perfect square trinomial when you fill in that blank. So in that blank, you're going to add in, on both sides, half of b squared, because that's the number you would need to make this a perfect square trinomial. Rewrite the trinomial as a binomial squared. Take the square root of both sides, remember your plus and minus sign, and solve for the variable. So let's look at some examples of this. So example 1 says x squared minus 10x plus 21 equals 0. So we check to see, is half of negative 10 squared equal to 21? So half of negative 10 is negative 5, and negative 5 squared is 25, which is not 21. So let's move c to the other side, and we're going to leave room for what would be a perfect square trinomial. So we're going to move 21 over. We're going to add the blank on each side. This way we could put the right number right there so that I can rewrite it as a binomial squared in my next step. So x squared minus 10x, I'm going to take half of the middle term's coefficient. So half of negative 10 squared, we've already talked about, would be negative 5 squared gives me 25. So what I've done is I've made this into a perfect square trinomial. So that way I can rewrite that trinomial as its binomial factor squared, because the factors of this would both be x minus 5. Then I can add these two together. So negative 21 plus 25 would just be 4. Now I have this nice smaller quadratic equation that I can solve using square roots, because that was my goal. So I want to take the square root of both sides. I will get x minus 5 equals plus or minus 2, because the square root of 4 is 2. Then I want to add 5 to both sides. So I would get x equals 5 plus 2, which is 7, and 5 minus 2, which is 3. So I get two values for x. So that one would be factorable, but it's also possible to use this method. Let's look at number 2. Number 2 is 2x squared plus 8x plus 2 equals 0. So it's all on one side, but a is not equal to 1. So we want to divide everything by 2 first. So I'd be left with x squared plus 4x plus 1 equals 0. Now we check to see if our trinomial is already a perfect square trinomial. Half of 4 is 2. And 2 squared would not be equal to this 1 right here. So we need to move it out of the way. So x squared plus 4x plus blank move that over so it'll be a -1. And the reason we have to add a blank to both sides is because with an equation we have to keep everything balanced and we have to add the same amount to both sides. So then let's take half of 4 and square that number. So that's 2. 2 squared gives me 4. So then we could rewrite the trinomial we've created. Now it's a perfect square trinomial because it has that relationship between b and c, and a is just equal to 1. So we write x plus 2 squared equals 3. I added those two together. Now I can continue to solve by taking the square root of both sides. So x plus 2 equals plus or minus the square root of 3. I can subtract 2, so we can leave this answer as -2 plus or minus the square root of 3. So that is an irrational answer. There are 2 roots and they are irrational. This one had 2 roots that were both rational and real. And these are still real and they're irrational. Let's look at one more example. All right, one more. K squared minus 4k plus 1 equals -5. So first things first, we got to put everything on one side to put it in standard form. All right, and then we check to see if it's already a perfect square trinomial. So is half of -4 squared equal to 6? Half of -4 is -2, and -2 squared is 4. We need this to be a 4. So let's make room for that 4. K squared minus 4k plus, we know that's got to be a 4 because we've already thought that out. Move 6 to the other side, so -6, and we also have to add 4 to that side. So the way I got the 4, remember, is half of b, which was -4, which gives me -2, and then you square that number. So it should always be positive. That's why we add a plus blank. It's always positive because you've squared whatever it is positive. So now we have a perfect square trinomial. We made it into one. So let's rewrite it as k minus 2 squared equals, and add these together, which will be -2. And then we can finish solving by taking the square root of both sides. So we get k minus 2 equals the square root of -2. Now here's where that's not a real answer, but we've looked at complex numbers before. So we can take out the I for the -1 under here and leave the square root of 2 because you can't simplify that 2. We just want to add this 2 to both sides. So we get k equals 2, plus or minus still needs to be there. And then we have I square root 2. So this is a complex solution. There are 2 complex roots is what we call this one. And there's one more thing I want to point out before we finish up. Notice on each example, if you go back, when you're rewriting this as a binomial, let me get another color. The trick to rewriting it quick and easy is you always put half of that number. So notice in each example, half of this number equals